Okay, next up we're going to talk about socket programming. So as we mentioned before, the goal is to learn how to build client-server applications that communicate using sockets. Basically, sockets are the API that allow your application layer program to communicate to transport layer. Basically, handing off any data from your application to the operating system, which uses the networking layers to send the data across the wire to its destination and vice versa. So we mentioned before, the socket is basically a door between the application process and the end-to-end transport protocol. So basically, as we're going to take a look at, and as you probably are already aware, there are two different socket types for the two different transport services. UDP, where we're going to send an unreliable datagram, and TCP, where we're going to send have a reliable byte stream oriented socket. So basically what we're going to do is we're going to set up a simple example, and this example is written in Python, and I also have on in the additional material these examples of the Java versions of these examples. But basically what we're going to do with the client very simply is going to read a character or a line of characters rather from the keyboard, that's your data, and you're going to send it to the server. The server receives the data and converts the characters to uppercase. The sender then sends the modified data back to the client, and the client receives the modified data and displays the line on its screen. So you type things in lowercase, and if everything works correctly, you see the items being on your screen back in uppercase. If you're going to try any of these programs in the lab as opposed to at home, keep in mind that any ports that are not well-known ports are going to be locked down. So you may have to ask whoever is running the lab permission to open up the port so you can run these programs if you're not running these on your own machine. Let's start off by talking about socket programming with UDP. So with UDP, there's no connection between the client and the server. So what we mean by that, there's no handshaking that has to occur before sending data. So you're going to see the command structure in the UDP client server will be different from that in TCP. Basically, the sender explicitly attaches an IP, destination, and port number to each packet. The receiver extracts the sender IP address and port number from the received packet. Keep in mind that the UDP transmitted data may be lost or received out of order. And basically what we're accomplishing here is providing an unreliable transfer of a group of bytes, basically a datagram, between the client and the server. So let's take a look at what needs to happen. So basically, in our UDP client and server socket interaction, we're going to have these following commands. And like I said, this is basically using Python syntax. Like I said, you can obviously do this with any programming language. The syntax will vary a little bit. So we basically create a socket and port, which is equal to X, and then we have our server socket command. So we basically say that we're going to have we have different parameters. We'll talk about the parameters in the socket command, but basically we're defining a socket called server socket. It's going to be an internet socket, and it's going to be a datagram, so it's going to be UDP. And basically what we do in the program, the assumption is the client is going to send us something. So we're going to read a datagram from server socket. We're going to do some work, and we're going to write a reply to the server socket specifying a client address and port number. So we send this back to the correct client. Continuing on, the client side, we create our client socket, also defined the same way. We create a datagram with the IP, with the server IP, and going to a particular port which we have defined. Like in this case, a user-defined port. We're not using a well-known port, and we send the datagram via client socket. We assume after we send it, the server sends us back something back. So we read that datagram from client socket, print it out on the screen, and then we close it. So here is our example app written in Python. So we start off at the top. We define our variables. We define our server name, equal to host name. We're going to use port 12,000 for our server port, and we have our. I recommend, if you're not familiar with the syntax for sockets, that you look it up. Basically, you need to have this from socket import asterisk, and it only works with certain versions of Python. I don't remember the version number that you have to use for this particular syntax. Then we define our socket. Our socket is going to have 2 data items. Basically, this AF underscore INET basically says that this is a socket that's going to be an internet IP connection, and we define it as a datagram, so it's going to be UDP. Then we use the raw input to get a string. We assign it to the value message, and then in the socket structure, and obviously you should probably look up the overall socket structure in how it's defined in Python. And you can also see very similar structures in C and in Java as well. But there's going to be a send to value, send to parameter rather, and you're going to pass it the message, the server name, and the port number. So when you do this, what happens is the operating system takes this information and sets up a connection with the server that should be waiting to read something from its socket on that at that particular port 12,000. Then the way the server is written, after it receives something, it's going to send it back to the client. So now we're going to give the variable modified message and server address the value of what gets placed into the receive from variable in the socket structure. And then once we receive that, we can actually print out the message, and then we can close using the close variable to close the socket structure. So like I said, we need to have this command. This includes the Python socket library, so it's aware of, we can take advantage of the socket structure that's already in the socket library. I recommend you do some research and look that up on your own so you can see all the definitions of the in the components of Python socket structure. Like I said, there'll be something similar in C, C++, and Java all have those socket structures. Then we create our UDP socket for the server. We get our keyboard input. We attach the server name and the port to the message, and we send it into the socket structure. Then we read the reply characters from the server, take a place in the socket structure into the modified message string, and then we can print it out. On the server end, what the server does, like with the client, we have to have this for to include that socket structure in our program. We are on server port 12,000. We assign our variable server socket to be a socket structure. It's going to be is the internet, and it's going to be a datagram, so it's going to be UDP. We basically then bind that socket to port 12,000, which basically says, okay, we're assigning this socket will be created to port 12,000, so anything that comes on that port is going to be sent into this socket structure. We go into this continual while loop, ready to receive messages. We receive a message which gets sent in once the client sends a message, because we're listening on this port, the server socket structure, the data gets put into the receive from structure, which can get passed to client address and message. So the client IP address is actually address and port is assigned to client address, and the message is assigned to message. We can use the upper command and to change the message to uppercase and assign that new value to modify message. And then we use the send to structure to send modify message, and we use client address to specify where we're going to send the message to. So like I said, we create our UDP socket here. We bind the socket to the local port 12,000. We loop forever. We read from UDP the socket, getting the clients, getting the message, and also getting the client's IP address and port, so we know where to send it back. And we send the string back to the client. So what happens with TCP? In TCP, it's connection oriented. The client has to contact the server, so the server process must be running first. The server must have created the socket that welcomes the client's contact. The client contacts the server by creating the TCP socket, specifying the IP address and port number of the server process. When the client creates the socket, the client's TCP protocol establishes a connection to the server TCP protocol. And then when contacted by the client, the TCP server creates a new socket for the purpose to communicate with that particular client. So there's one socket waiting for the connection, and then the other socket for the actual communication. This, of course, allows the server to talk with multiple clients, and there's a source port number used to distinguish between clients. We're going to cover this in our in next week's lecture in more detail. And basically what happens here is that TCP is providing a reliable in-order byte stream transfer, basically a pipe between the client and the server. Okay. So here we create our socket structure. We assign a port to a particular port number. We set up a server socket to be a variable of the socket structure type. We wait for an incoming connection request. When it comes in, we accept it. We read the request from the connection socket. We write a reply, and then we close. On the client end, we create a socket. We connect to our server ID on the port that we know we're supposed to connect to. We assign a value client socket to be a socket data structure. We send a request using client socket. We read a reply from client socket, and then finally we close. So this is what the client looks like in the TCP version. So we've already talked about this stuff already. Don't have to go over that again. When we create our socket, instead of being a datagram, it's going to be a sock stream. This means we're going to be using TCP instead of UDP. We're going to connect to the server. We're going to gather our data from the command line. After we connect, then we're going to send. And after we send on that same socket, so we have a connection, we'll be able to receive the modified sentence, and then we can print it out. Here on the server end, we create our socket, like I said, using sock stream instead of datagram. So the next thing we do is we bind the socket that we've created to a particular port number, so it knows to is going to associate that port number with this particular socket. Then we listen for incoming TCP requests. We can set a queue value, so we can have set up for multiple simultaneously requests with a queue. Right now we just have a queue the size of 1. We loop forever. Now we have the accept. So when something comes in, we accept it, and the values once we accept something, then we can use the the receive buffer in the socket data structure and send that data and assign it to the value sentence. We can use the upper function to change it into uppercase and assign that new value to capitalized sentence. Then we use our send data structure to send capitalized sentence the value back to the client, and then we can close the socket. Notice, whoops, let me do that. Notice we have two different sockets. Okay, we have this socket that's listening, and then once we get something, we have this new socket, this connection socket, that's going to actually accept the connection, and this is the socket that we're going to receive and send data on, which is separate from the socket that's listening. So this allows us to be listening on this one port and set up unique connections if we have multiple clients communicating with the server. That's all we have for this section, and next up we'll be discussing network time protocol.